It's not really the greatest place for that, is it? Put it over there. Maybe? All right, we have some items on the whiteboard we're going to discuss. We're not going to talk about more loops. Loops, that one's stricken from it. Are you ready to do Q&A with Mastermind? Some of us have started on Mastermind, right? Should be well underway. Do we have questions ready? You want me to talk about object-oriented programming while you think of your questions? Yeah? All right. Well, think of some questions because we actually have to have that section afterwards. Object-oriented programming. So this is something totally new, and it's going to confuse you, I promise. So don't freak out, rule number one. And also don't freak out because it's not until next week, technically. You know, I like to try and keep us working ahead a little bit, but we got a little bit of time. So what is object-oriented programming? Apparently it's the real deal. If you guys can read that. Let's see if I can. It is debatable, says Zach. Yeah, I think you're right. So I'm just going to talk for a second conceptually. Basically, what object-oriented programming means is instead of doing all the things that you want to do by writing functions, you're going to write a special kind of function that makes a thing. It's going to return like a more complicated thing than we have been returning so far. So far we've been doing a lot of true-false solutions, right? Things that do things, right? You like mutate the board, you change the player turn, whatever, and then you return maybe nothing, maybe undefined, right? You've already done your thing, so you don't really care about what comes out. Now we're going to return something more complicated that, quote unquote, I'll say this a lot, that knows how to take care of itself. Okay, so we already know you can use objects, right? Curly braces to store keys and values, right? You can have keys that have string values or array values. You can nest objects inside other objects. But still, all of that has been very static, right? Those things are. And maybe you go in and change them for the homework once you figure out how to change Fred Astaire starring or whatever it was. God, who wrote those? That was random. But those things are pretty static, right? Unless you specifically go in at a place and you make the data different by using like an equal sign, right? Object A at key whatever equals new value. So that's like a very intentional action you have to take. Instead, what we're going to learn now is how to make objects that know how to do things, have actions associated with them instead of just data. And they can sort of change themselves to meet your needs. So let's look at some examples here. This should look pretty similar on this first line. What's different on that first line from normal? Just off the top of your head. Super basic. We don't usually call our functions like that, right? Or we don't usually declare them like that. What's different? Really obvious. Don't overthink it. Capital letter. Yeah, that is a convention. It is not a rule. It's not enforced by the language, but it's a convention that this says this is a special kind of function that you're going to call a little bit differently, and it's going to give you something special. In this case, what it's going to give you is a human. It's going to build a human for you, and that's what you'll get back. So if you think of this, I always use the analogy with a factory or an assembly line. The way this works is you'll call this function very similarly to how you would normally call a function with one caveat, and there's this implication there. It takes a thing and it starts building it up for you. You can think of it as like steps along the assembly line. Step one is to assign to it a property called planetary origin and give that property the value Earth. Okay, so we call them properties in this case. We don't really call them keys so much like we did with the old kind of objects. You can still say key, it's not the end of the world. The exciting part is the second step in the assembly line. What's different about that? We're still just taking a property and assigning it a value, but that value looks different. right? What's different about that second value that we're assigning in?
You're not naming the function.
We're not naming the function, but it's a function, right? That's actually what's going into the object at step 2. We're actually assigning a function as a value stored in that object's property. Okay? So once I don't think this doesn't actually do anything. There's nothing scrolling down there. The way that we know we're building up things, we're actually like doing steps in the assembly line, is this fancy keyword called this. And it gets confusing when you try to describe what this is, because this is also a very common word. We'll have lots of laughs about that. But that's the keyword. That's what tells you that we're actually building up this object as we go along. And when we assign in a function like that, we call it a method. I often just casually refer to them as verbs. So once we build this thing, this human, we'll actually be able to not only look at its planetary origin property, but we'll be able to call its explain yourself method, and it will know what to do, right? We will have already taught it what to do, and it'll be able to exhibit that behavior. So let's see an example of that. Here we go. So don't worry about this part yet, but basically what we end up with is a human, right? Somehow we do this assembly line, and what we get out is this thing that has the properties and behavior that we've designed, right? So it's higher level than this game stuff we've been doing, right? In the game stuff, we just go and update the state that we already have. Now we're building things that have properties and behavior that need to match up with what we want them to do. So this should convince you here that human 1 knows how to call the explain yourself method, right? That lives on this thing that we built because we gave the JavaScript gremlin instructions on how to build it, right? So that's what this top function thing, it's how I usually describe it, right? It's a set of blueprints, right? It's instructions for the assembly line workers that tell them how to build the thing so that it works right. And then what you get back is the thing, right? You imagine the factory, the conveyor belt that sticks out of the roll-up garage door, right? And it just kind of slides off, right? And that's what you get. You get the thing that you taught them how to build. It's kind of like, I don't know, it's not like IKEA, because IKEA, you got to build it yourself, right? But it's like, Henry Ford or whatever with the assembly line and the Model T. So let's run these so I can convince you that that's true. I think I clicked it, yeah. Oh, maybe not. Oh, there we go. Oh, it did it. So this console log logs the value that comes out of human1.explainYourself. If you look back up here, look, that's the value that gets returned by that function. So we can call that function a lot like we call any other function, only this one lives inside this object that we built. And then we can access properties in the same way that we do with normal objects, right? That one's not too scary. Now we build on the example a little bit. I guess I could talk real quick about the main difference, the way that the language feature that makes this new factory building paradigm possible is this new keyword. This is saying, okay, we're going to use a class here. We're going to use these blueprints that you told me about, and that's how I know what to do with this keyword, right? That's how I know that I need to attach behavior to this, and it needs to know how to take care of itself. Number 1, we use a capital letter. Number 2, we use the new keyword. All right, so let's make it a little more complicated and a little more interesting. Let's see, do we ever? We don't. That's not quite as interesting. So I'm going to modify this example on the fly a little bit. Here we've added a few properties. We've introduced this new syntactical element where we pass parameters. We've seen parameters before, right? Not a huge deal. But now, these are things that we can use as we build up this factory object, right? As this thing comes across the assembly line, we can say, well, they're not all going to get the exact same planetary origin. Okay, that's one. Humans usually tend to have the same one, right? But as we add new properties to human, like name and gender and hobby, They don't all get the same. So we need to be able to customize them. All right, so the way we do that is we say, okay, factory worker, I'm going to tell you when the time comes to build these things, this is going to be a particular batch, right? This is how we're going to build this batch. We're going to build females that have a particular name and they're going to have this particular hobby, right? And with those specialized instructions, store those new values in this thing that we build. So let's see what that does for us. Should return the last value, I think. So we should get Laura down at the bottom. Yeah, so here's the Laura variable. Here's the Laura human, right? When we called new human for Laura, we give it a name, right? And we give it a gender, and we give it a hobby. And those things got stored, right? Those specific values that we passed when we told the factory to construct the thing that we wanted it to have. So you can see that those got stored in there. And then there's this defaulted value as well, right? Not everything has to be configurable, right? Some things are going to be the same for all instances of a class. I'm going to start to use the terminology a little bit. This is called a class. And the things that you build when you invoke the class name with the new keyword, these are called instances, right? It's a particular instance of a more common type. So we see that we can not only assign configurable values passed via the constructor, that's also what we call this. The class name, when it's used like this, is called the constructor function because it constructs instances, right? We can not only assign configurable values, but we can also just do defaults, right? Just hard code earth. We want them all to have earth. Okay? I think probably the coolest piece about this is we can use the object's values to make its behavior unique, okay? So this .explain yourself always does the same thing, right? But the whole point is to teach objects to take care of themselves and sort of do things that are specific to their values, right? So if we wanted to say something like, say hello, that sounds like, first of all, does that sound like a property or a method? Is that like a noun or is that a verb? It's a verb, yeah, it's a method. We need it to do something, right? So when we call this, we're going to call it with parens. It's going to be a function, okay? So here's a function. And we won't pass any parameters. But in here, I can say, I'm going to have it console.log directly. I'm not going to log it when I call it. I can log something specific to me, right? I can say, hello, my name is, right? And now I need my name, right? The name that I'm being built with, which I don't even really know yet, right? I only know it because it was just attached to me in the last step of the assembly line, right? It was assigned in right here. So I actually do have access to it, and it lives here. Let's see if that works. When I want to call this, I have to say which particular human I'm talking about. I'm talking about Laura, who we just made, right? And I invoke it as a method, right? It's a function that lives on her, right? She knows how to do this. And this function doesn't take any parameters. I think that should work. Okay. And then what if I wanted Todd to be able to say hello? Do I need to do something up here, like add another say hello just for Todd? No, I taught them all, right? I taught them all how to do it. So do I need to change this at all? No, every object, every human that ever gets created will have all of these behaviors, right? The configurable ones that we pass in the constructor, and these verbs, these methods that we, when we define them, we teach them how to use the existing state of the data that's stored in the object. So let's just tell Todd to say hello too. Cool. Okay, that's pretty exciting, right? You see how that's really qualitatively different than what we were doing? We were just like logging out a hard-coded value. But the object knows about itself, right? So it can do different things depending on what state it's in. Just to prove that to you, let's mess with Todd. All right, so Todd.name, that's going to be Todd, which is the value we assigned in the constructor. Let's update it, right? I can do what I want. And we're going to call him, he's not Todd anymore. All right, so now when Todd says hello, what's going to happen? Any guesses? I'd say there's 2 reasonable guesses. Fine, interesting. Hello, my name is? Not Todd anymore. It's going to read the current value that lives in Todd's name. I hope. We changed the whole world, right? We're playing God by messing with Todd. I don't know. So hopefully that just convinces you, like, there's a lot of power here. As our systems get more complicated, we might build these apps differently, right? Board might not just be a plain old array, right? Maybe board has like a state that holds all the markers, but then it has a method that says set mark, and it takes row and column parameters, right? Now you don't have to remember everywhere in your function, okay, what's the current state of the board, and how do I make a mark again? Oh yeah, the board's an array, so I have to go into the row and then the column. I guess I'm doing tic-tac-toe in my head here, right? So I have to go to the row and then the column and make a player turn mark. It's like, no, you don't care about any of that, right? You just say set mark, right? Or play turn, or whatever the action is that you describe, and it knows how to take care of itself. And so you can start to carve off pieces of your system, usually by like modeling the system as far as what the physical objects would be, right? That's hence the name, right? Object-oriented programming. And so you can model these systems in ways that make sense to humans so that you can continue to reason about them as they get more and more complex. Anybody have any questions on any of this yet? I'm going to stop there, I think. I don't think there's anything else in here. Yeah, pretty much done with this lesson anyways. We do a loop here and we make a whole bunch of humans, but that's not too exciting.
So essentially you're making like a mold of code that you can reuse. You don't have to create the mold again, essentially.
A mold, yeah. I mean, that's another awesome factory analogy, right? Like, yes, you make the mold, you design the mold perfectly, right? And then all you do when you call new is you pour the whatever in, and then you press it, and then the thing comes out. I don't really know how molds work exactly, but that's kind of the idea, I think, right? And then the thing pops out, like Jell-O. That's what I think of. Okay, so in the app for next week, it's a space travel to Mars. It is, spoiler alert, it's not really an app. This is more of just like an exercise in getting the tests right. You can still run it with Node, but there's no interactive loop. Excuse me. There's no get prompt. There's no rows and columns or anything. It's just a scenario. And if you want to debug it and you want to play around with it, once you declare your classes with capital names, it'll be capital S ship and capital C and M crew member. Those are the 2 objects you'll be working with and designing. At the end, after you've defined those behaviors, you can make some, right? You can make ship number 1, right, and ship number 2, right? Now you can build them, and they're going to interact with one another, right? So you can make a ship and a crew member and call the appropriate methods, and you can log some of their values, right? That's how you'll debug that app, not by playing the game. Does that make sense? Yeah, it'll make more sense next week. We'll talk about it some more, but that's the basic idea. Also, I want to just encourage, like, and instill this in you, is that where you define the behavior, where you make the mold, and where you actually fill the mold and make a press and get a thing out, those are very different things, right? And I want you to think of them differently as far as temporally, right? Different in time. You define the behavior first, right? And you do the instantiation. You make instances is what instantiation means, right? You build the instances, you do the new calls down at the bottom at a different later point in time, right? Just like with functions, right? We have function declarations, and I always ask, right, like, does anything happen yet? And it's like, no. The JavaScript gremlin just takes the function and kind of holds on to it. And it's not until it's called later in the code that the actions actually happen, right? This is much the same. Okay, that's OOP, object-oriented programming. You're all experts now. All right, Q&A on Mastermind. Now you have to actually have some questions because I gave you special extra time to think about it. What kind of questions do we have? Does everybody understand how to play the game? Yeah, it's kind of tricky. I'm actually not very good at it, but I do know the rules. We can play. Let's play. We can play.
Hard-coded solution, it gets really hard.
Well, yeah, it's hard. The game is definitely hard. That's not a legit complaint. All right,
It's
so
harder on, just a text-based.
yeah, that's the main thing I think. When you look at this board, you're like, wait, this is the game we're playing, because we don't have any of these things, right? I don't have green, I don't have yellow, and when I play, I don't have reds or whites. I guess I didn't get any there, so that's not a very great example. Come on. Surely one of these has to be at least a white. Okay. I don't have those either, right? And that's okay. What we're working with instead of colors are different letters. What we're working with instead of reds and whites on the right-hand side are just counts. Because the positions of these don't actually mean anything, right? We just look at these and count them and say how many reds are there and how many whites are there. And that's all the logical information you can get out of there. So when we're coding the app for ourselves, whenever you see color, you need to think letter. Whenever you see reds and whites, you need to think correct letter locations and what's the other one they call it? Correct letters, right? Those are the two counters, two counter variables. I know that's sort of a decent sized mental leap. I'm sorry. This app is kind of hard. As you play the game, what this has taught us is that, actually, why don't one of you tell me what this has taught us? What does one red mean?
Means you got it in the correct position.
Which one?
The first one, far left.
The first one far left is an awesome guess, and that's misleading, right? That's the misleading thing I want to catch here, is that we don't know which one. That's the part of the puzzle. Like this upper left means nothing. It just means that one of these is right. And actually, if we think of our first guess, we know
It's not red.
that it's not red,
Okay.
right? Because there were no reds or no feedback here at all. So one of these is in the right location. I really don't know the best strategy for this game, so we're gonna see. Maybe it's, I don't know. Move the blue around? No, don't move the blue. Put in a new color. I really don't know how to play it very well.
So the red is in the correct, from the rules of the game, red means it's in the correct color and correct position. White means it's just the correct color.
Right.
So you got it right.
Your
The
first
yellow
position, left,
No,
red is correct.
the position means nothing.
Yes.
Like-
The
like
fact
the
that this
position
red
that
guy.
is all-
One of those is in the right.
Yeah, the little 4 on the right, when it says the red dot, from the rules of the game at the bottom, the instructions, it says correct color and correct position.
Yeah, but it didn't tell you which position.
Right.
It's in.
It's in the right
Yeah,
position,
I see what you're saying.
but we don't know if it's which of the colors is in the correct position, right? It's not
Yeah.
telling us that it's the green or it's the blue or it's the yellow. We know that one of those
Okay.
is the right color and in the right spot, but we don't know which one. And the only way we know the red is not the right one is because we look at our previous guess and say, oh, I guessed all reds
Okay.
and I got no output, so red must not be in it at all. So we know it's not red. So now we know that, okay, we have one in the right position and the right color, and two of the rest of them are at least the right color, but we actually know for sure that they are not in the right position.
Yellow
Right.
has to
Not necessarily.
Not necessarily. that's like a
Actually, no, yes,
Yeah,
because
because
it
no one
was the
changed
only one
the
from the
color.
previous one.
no other colors. But I could have introduced a new one that is in the exact right location, right? And yellow could be the wrong one. That's what's so hard about this game.
Yeah.
So I definitely think like yellow is a solid guess, but I don't think it can be logically concluded for sure yet. And I want to stop playing because this game just gets harder with every turn, and I don't want to record something really stupid. So I'm stopping. You can't make me keep playing. Does that help at all? I don't know. Just talk it out a little bit. Know that the colors are letters, and the reds and whites on the right are just counters. Those are actually, each of our loops counts up one of those, right? We have one loop and then the next loop. Questions? Q&A?
I do have a question. On the generate hint in the for loop, the solution array I equals null. And
Yep,
its instruction
I'm with you.
said to make set that index in solution array to null.
I agree.
Why is that?
Okay, so the first loop, are we counting reds or whites here? It's okay if you don't know.
We're counting, well,
Cor- what are we calling the counter? What's the name of the counter? Correct letter locations. So if it's in the right location, is that a red or a white?
it's a red.
It's a red. Okay, so we're counting reds here. That's good to know. These are like the really right ones, right? Like, don't move them. Okay, so as we go through, when do we set the solution I to null? Solution at I to null?
Whenever you
Not all the time, right? Otherwise, we just null out our whole array.
No, only
Right.
if the guess equals the solution.
What does that mean, though?
It
If
means
the
if you
guess
have a
equals the
correct-
solution,
If you have
Line them up
correct
in the
guess.
right order.
line them up in the right order. Specifically, what does it mean to have the guess at I be the same as the solution at I? I think you were right there. Just say that again.
That they are in the right position.
Yeah, it means that that letter that you're on is exactly right, right?
Yeah.
So why would we null out that letter in the solution? We're getting rid of it, right? So now if I say A, B, C, D and my guess is A, right? That first iteration nulls out my solution A, right? We increment the counter, but we null that out. So I'm left with B, C, D to work with for the rest of my loops. Why might that be?
Oh, okay. So that you know.
You know, but why? Anybody have any help here? Why would we get rid of that guy? Why can't we leave him there? Don't want it to loop again.
So duplication.
Yeah, we don't want to see that guy come up in any later iterations or in the next loop, right? When we count the whites, we don't want to count that A anymore, right?
Yeah.
Because if I just get one of them right, ooh, perfect example here, right? I just got one of them exactly right. He only showed up as a red. I mean, technically he's the right color too, right? So he's both the right color and in the right spot, and he's just the right color. We don't want to count that as a red and a white. Does that make sense? We don't want him to show up as two
Oh, okay, gotcha.
units of output. We just want him to show up in the first one. So we get rid of him so he doesn't get caught and reported in the second loop.
Okay, gotcha.
It's hard to do without actually writing the code. I guess I could have just showed you the code a little bit, but
Yeah,
instead I just waved my hands around a lot. Any more questions? Anyone want to see me dance around some more? The last thing I want to say is Leslie had an awesome idea in homework or in App 6 when we're doing these new class things. Remember on Tuesday I alluded to the fact that we're going to learn a little bit of ES6, also known as ES20, 16, 15, I can't remember, 16 I think. If you get that working, here's how I'm going to say it. If you get that all working and all your tests are passing and you understand it, I would love it if you would switch from using this notation to the new keyword, which is implemented in the new language features, called class. We actually can type the word class, and it does a little bit of this stuff for us. Okay, I'm not going to show you any of that. I'm not going to say any more about it. But there is a newer, cleaner, nicer way to write these exercises that we're doing with the space travel to Mars. And it would be awesome if you would switch them over at that point. Under the hood, the code is virtually identical. So it still works the same way. It's just a new syntactical feature so that it looks kind of like other languages do, right? So it's the whole idea is to conform to sort of this more cross-language. This is how object-oriented programs in any language tend to look. So that's why they implemented this feature. So just keep that in mind. I would love it if you would do that. But definitely do that after you get everything working. I don't want you to get confused along the way.
It says that we have 2 apps due next week. Are they both due on Thursday? Space Shuttle, Mars, and Checkers.
I don't actually have a grade in there for that one, do I? In Campus Manager?
It doesn't show us anything past week 5 work outside of class. So
Oh yeah, then neither of them is in there. Checkers is a bonus app. So let me just say that on the record. You do not have to do Checkers. It's a good one. It's a good one to do for sure. It's a little bit tougher, but it's a good one. It's really solidifies some of the object-oriented concepts. Kind of like I was saying, how you teach it to set a mark, right, and take care of its own state. So the rest of the program doesn't have to know all that fancy stuff. It's a really good one for that. Highly recommend that you do it, but it will not be graded. Or it'll be graded as bonus, whatever that means. Good question. Thank you. Any more? Anything from our TA? Any words of wisdom? Nothing.
Not that I can think of.
All right. Thank you for your attention. What are we working on now? If we don't have Mastermind done, we're working on Mastermind, right? I want to call it Minesweeper. If you want to build Minesweeper, that's a good game too. And Homework 6 is actually a little bit better. Wasn't somebody just working on Homework 6? It's you. It's a little bit better than the other ones, right? That's a no. Uh-huh. Yeah, sure. It's great. Love it. Yeah, thanks. All right. Okay. Thank you for your attention. That's all. Nope, not there. Oh, God.